Yo, what's up? It's time for lesson 92. Today we're going to be dividing polynomials. You know what really messes with people that do these things? You take a corner and you twist it like that. So when you mess it up and they think they solve it, they like can't do it. It's so funny. Except this one's mine, so I should have done this with somebody else's. Oh, that was dumb. Right. Okay. Hey, folks. Oh gosh, that was like blurriness. Look at this. This is something we've done before. This ain't so bad. Multiplying a polynomial by some other kind of polynomial type of dealy thing. This is just distribution, right? We take this times this, and then this times that, and that times that. We did it kind of like in a grid, yeah? But what in the world does this mean? What does that mean? Because, oh man, it's like this, right? Let's divide some cubic polynomial by a line. I don't know, man. So what are we going to do? Well, we can kind of reverse engineer this thing and break it up into pieces and take these pieces and think about what they mean and make a big problem into a simpler problem, hopefully. We know that with fractions, if everything's over one fraction, it's got multiple pieces, we can just break it up into individual kind of tiny pieces and then see if there's some factoring that we can do. Okay, so here we would think, what's 8 divided by 4? That's 2. And what's x to the third divided by x? Well, it divides an x out, so I'm left with that. Here in the middle, I got 12 divided by 4 is 3, and x squared divided by x is just 1x, and 4x divided by 4x is 1. So that's what it means. And if I want to double check, well, why don't I just multiply 4x back in, undo what I just did, see if I get the same answer that it would have started with, just to double check. And I would get 8x cubed, and I would get 12x squared, and I'd get 4x. And by putting the 4x back in, I got to back where I started from before I divided that 4x out. That's what we're doing, okay? We're going to divide a polynomial by another one. And sometimes it's a simple thing like 4x, and sometimes it's not. Case in point, I got this second one up here, where I'm dividing basically the thing that makes a parabola by a line, x minus 3. And at first you're like, I can't really do the same thing I did over here and break this up into pieces, because what's x squared divided by x minus 3? I don't know. Or negative 6x divided by x minus 3? I don't know. Or how about 9 divided by x minus 3? I don't know. But what I do know is that that top problem looks awfully familiar. The patterns that we've been looking at, of the division, the factoring that we've been doing with polynomials. So what is this like this? Because if I can do this with it, then maybe one of the factors is this, and I can cancel stuff out. So we look here and we're like, 9, that's a square number. That's a square number. And the pattern was, well, right away I can tell what the pattern was from lesson 50 something or other. We did a long time ago. That this one factors down into x minus 3 times x minus 3, right? X squared minus 3x minus another 3x plus 9. And lo and behold, there we go. If I cancel this out, that equals 1. So there's my answer. X squared minus 6x plus 9 divided by the factor x minus 3 leaves me with just x minus 3. So a little bit of simplification goes a long way here to making this problem a lot more manageable, because I take a more complicated thing and I break it up into simple pieces, and then I could do some simple math. Now, not all of them are super simple. Obviously, we can make this more complex, and we will. But we'll also, if you hang on, maybe you come back later, we do the enrichment. Depends on how much time we've got. I can show you how to do this even faster. Oh yeah, that's what you get from all those years in school. So let me throw some more up on the board. We'll try a few more types of problems, but basically we want to take a lot more complicated problem, make it a simpler problem, and then do some basic math with it. Okay? Don't be scared. Don't be scared. I'm back, you're back, we're back. It wasn't long ago, was it? Oh, golly gee. So I got some bad news here, folks. Remember problems like this? Remember problems like that, and you're like, oh, there's so many rules. I go this, and then I go like 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 this, and I go like this, and I go like this, and 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 then checking it and all that stuff. Oh gosh, stab me with a fork. I hate that stuff. It's so long. There's shorter ways to do those problems, and it's such a pain in the neck. And golly, guess what? They're gonna make you do that kind of stuff with polynomials. I mean, who makes this stuff up? Why don't they figure out easier ways to do this? Like, I don't know, do it easier, like ways that you know how to do it easier. Like, crying out loud. You see that that top thing is factorable? Do you see it? I see it. It's an x plus 1 and an x plus 2, isn't it? And so I know that this is going to do one of these kinds of things again, but they don't want me to do it that way. They want me to do it the long way. Well, fine, I'll do it the long way. Oh. That means the long way means we got to do junk like this. X squared plus 3x plus 2 and set it up like one of those long division problems. Any problem that has the word long in it's a bad idea in math. Gosh. Nevertheless, we shall persevere. And all right, so here we go. This is kind of yucky, but just watch, okay? And something down here times this x is going to equal that x squared. I got to get rid of it. I know that x times x is x squared, but lo and behold, there's a plus 1 there. What do? Oh, well, x times a plus 1 gives me a plus 1x. Oh, well, remember, we have to subtract. That's how long division works. X squared minus x squared is 0, but 3x minus 1x is 2x, and carry this down, plus 2. Okay, well, something, doggone it, times x plus 1 equals 2x plus 2. I believe that's a 2. And we do the multiplication. 2 times x is 2x, and 2 times a plus 1 is a plus 2. And that minus itself equals 0. Therefore, if I divide x squared plus 3x plus 2 by x plus 1, I get x plus 2, which I already knew that because I did it the other way. But nevertheless, we still kind of have to be okay with this because later on in higher math, you still actually have to do this on some yucky, sloppy problems. Copy it down, would you please? And if you can find a faster way to do something, please do it that way rather than this long division stuff. Synthetic division. Look it up. Ask a question about it. It will like amaze and astound you. Here's another one. And there are methods for factoring that top to see if x minus 8 is one of its factors. Actually, x minus 8 is one of the factors, but what's the other factor? Splitting and clumping would answer that, but for now, we'll do it the yucky way, which means I'm going to do this. I'm going to work it this way. And my first question is going to be, what times x minus 8 is going to help me at least get through that 3x squared part. And 3 times x is 3x squared, so that's where I begin. But there's also this minus 8 part, so I have to go 3x times that negative 8, and that will go right here, and that is a negative 24x. I've got to take the first thing minus the second thing. 3x squared minus 3x squared, 0, but negative 25x minus a negative 25x, or plus 24, sorry, 24x is minus 1x. Carry down the 8. What should go here that gets multiplied by this that makes this? Well, negative 1 will. Negative 1 times x is negative 1. X and negative 1 times a negative 8 is a positive 8. And that thing minus itself is equal 0. So that means that 3x squared minus 25x plus 8 divided by x minus 8 would have equaled 3x minus 1. Or I could say it another way, as this is set up right now. I can multiply both sides by x minus 8, and I could say that that equals that. Just factored it out, or I divided it out, and that's what was left. Wow. Wow. Mom. Yeah. That's not fun. I like my 3 other ways I have to do those. Well, actually, 2 quick ways to do that. But that's, you got to do that sometimes. You do it when you have to do it. On all these, it was really nice that it factored out. There was actually no remainder at the end. And yet again, not all of them are like that. Sometimes we do have leftover garbage. And case in point, example 4, I'll rewrite it so that it's a little nicer. We're supposed to divide this by x minus 4 when we're all done rearranging. Oh, golly. So, yeah, that doesn't look like it's a factor of this, but we'll see what happens here. I know that 2x times x is enough to get rid of that 2x squared, but I have to do this part as well, and I get negative 8x. And I got to take the first thing away, second thing away from the first thing, 2x minus 2x, that part equals 0. Negative 7x plus 8x gives me a plus 1x, carry the 9 down. And how many times does that go into this? It goes into it once. And when I do the math, I'll get a minus 4 here. So unfortunately, when I'm all done, negative 9 plus 4, I'm left with this that I've got to put here, which actually means 2x plus 1 minus 5 over the original bit. There's this leftover remainder garbage that's still sitting out there, and that's super yuck, but you can find it if you do the long division. Later on, we'll talk about what that remainder might actually mean in terms of polynomials, but you don't really care right now. So there you go. I got one more to show you that also has a remainder, but it has one more trick. We're going to add one more layer of weirdness to this problem, these types of problems. The original problem being this. And I'll rearrange it a little bit here first. You notice that it's a cubed and then just a single x. And so if we do long division, we have to do one extra thing here, and that is leave a space for the x squared. We have to leave like a placeholder. It's like a 0 in the number like 3012. We have to leave a space there. And what we're going to do with this is we're going to put in a 0 x squared in there so that we have a column for everything. We need a placeholder. We need a placeholder. So that when I do this first bit of division, I can have something to line up here. Show you what I mean. How many times does 3x cubed go? How much does that go into this? It goes in like 3x squared times. That times that is 3x cubed, and then I have to do this, and where's it go? See, it has to go right here. I wouldn't have had anywhere to put that and line it up. I'd be trying to take that negative 2x and subtract out negative 9x squared. But that doesn't work, so now I got a column for it. And 0 minus negative 9 gives me 9x squared, and I carry on with now the remainder that drops out. I gotta go fast through the rest of this, so I'm just gonna keep doing math, and you're gonna watch. Negative 2 minus plus, okay, so it gives me a plus 25x. Drop down this 5, and we'll put in here lastly a 25, and I get 25x minus 75. Negative makes me get a remainder of 80, which is yuck, but that's what it is. And so that's what we're going to go with. There's a few examples of that. Do some more in class. Ask me about synthetic division if you dare.